Okay, this is question 4 on acid-base problems. And the question 4 is about quinoline, which is a anti-malarial drug related to quinine. It has a molecular formula of C9H7N, and the question tells us that the pKb is equal to 9.5. The question also says that a saturated solution is about 1.6 grams of quinoline for 100 cubic centimeters. So we've got several little problems here that we have to solve first. First, we need to find out we need to convert to moles. And B, we need to convert CM3 into DM3, that is cubic centimeters into cubic decimeters. This combined to find the concentration. And C, we need to work with pKb to find the Kb for quinoline, sorry. So the first part is really easy, I suppose, because what we want to do is we want to find out what the pH of this type of solution, this saturated solution of quinoline, what the pH of that solution is. So let's write down the information we need here. We know that carbon is equal to 12.01. And hydrogen is equal to 1.01 molar mass. And nitrogen has a molar mass of 14.01. And if we do the conversions here, then we see that quinoline has 9 carbons, so 9 times 12.01, which is equal to 108.1. And we have 7 hydrogens, 1.01. It's going to be equal to 7.07. And then we have 1 nitrogen, equal to 14.01. That gives us a total molecular mass of 129.2 grams. That is the molar mass of this particular substance. If we then convert to moles, which is our first job here, A, let's write A over here, then we can see then that we can take 0.6 grams divided by 129.2 grams for 1 mole of this stuff. All right, equals 4.64 times 10 to the minus 3 mole of this quinoline. The second part of the question then requires us to figure out B, which is then 100 cubic centimeters. Because remember the concentrated or the saturated solution was 0.6 grams, in 100 cubic centimeters. We do the conversion. We should know this conversion, but I guess I can write it out. So 1 dm3, 1000 cm3, which makes then 0.1 dm3. So combining those two then, just like up above, we got 4.64 times 10 to the minus 3 mole divided by 0.1 dm3, which equals 0.0464 moles per dm3. That's the concentration of the concentrated quinoline solution. So now we need to move on to part C so that we can figure out what's going on with the equilibrium. So, C, if the pKb is equal to 9.5, then the 10 times 10 raised to the negative 9.5 power is equal to the Kb. And that turns out to be 3.16 times 10 to the minus 10. A very small number, assuredly. So, now we can take this value and this value and use it to find the dissociation for this particular base using the ice box. So let's think about what bases do. Base dissociates or reacts with water to form BH plus OH minus. There is an implied water here that we're going to ignore. Not because it's not important, but because the change in concentration for water is so small that we're not going to consider it. And there is no change in concentration. The change in volume due to water is not that large, and water cannot have a concentration in water. Sorry, I need to clarify that. So we already figured this out, 0.0464, and this we don't know that, and this is going to decrease by x, this is going to increase by x, increase by x, all according to the logic of the ice box, baby. All right, 0.0464 minus x, x, and x. Given that this value is so small, we can assume that this x will have no effect whatsoever on this concentration within the 3 or 4 decimal places that are presented. So we can ignore that x. And we can write the Kb in the following Kb expression in the following way. So Kb equals 3.16 times 10 to the minus 10 equals x squared over 0.0464. And remember, there is an x minus x here, but we're going to assume that it's so small that it doesn't change this value. Then we can rearrange this so that it becomes 3.16 times 10 to the minus 10 times 0.0464 equals x squared. If we then take the square root of each side, we're left with an x value of 3.83 times 10 to the minus 6 And this will be equal to the OH minus concentration. Now, we know that the pH plus the pOH must equal 14. And since we're finding the OH here, we can take 14 minus the log of, minus the negative log, of 3.83 times 10 to the minus 6 should give us the pH. And the pH is 8.58. And that is the answer.